looking at the first chapter of Pure 2, which is Algebraic Methods. We're going to be doing this slightly differently to the book. We're going to start at 1B and C, I think this is, D and E, F and G, and we're going to come to 1A at the end, because 1A is actually the most difficult part of the chapter. Okay, it starts off quite nicely. It's not too bad at all. You might spot that there's mostly GCSE sort of stuff to begin with. Partial fractions, this will be relatively new, but lots of similar ideas like comparing coefficients. 3, algebraic long division from year 1 will come in useful here, and then it turns into the same kind of question as part 2. Proof by contradiction is quite tricky. So we're going to have a go at these questions. It starts with multiplying and dividing fractions. So what can we do? Well, if we have the same factor, top and bottom in this situation, we can cancel it. Okay, so obviously I can cross those ones out. That's just C over B. Let's apply the same principles then. If I have the same factor, I can cancel it out. Well, don't seem to have that at all yet. Not much useful I can do on the left. On the right, hopefully you've spotted this here is the difference of 2 squares. So we factorize and we see what happens. So we'd have x plus 1 over 2 times the 3 is still there. And yes, that's x plus 1. And then that's x minus 1. And now this is the same situation as before. You have the same factor in the numerator, any numerator, and the denominator. Okay, I suppose we could go like this. We cross these out. And what would I be left with here? Not 0, I'd be left with 1, wouldn't I? Okay, when something divided by itself, it's 1. Over here, I'm left with x minus 1. Okay, so multiplying the top, it's 3. And then it's just a 2, and I'm going to leave it like this. Okay, next question. Division now. So division, we remember our keep, our flip, that means using the reciprocal, and then changing the sign. So this is the same as P over Q times by the reciprocal, which is Q over R. Cross out, multiplying the top, there's a 1 there, there's a 1 there, so P, 1 times P is P, and then 1 times R over R. Again, straightforward GCSE stuff. Also sort of GCSE, something like this. On the left, we see there's not very much that we can do. On the right, it looks a bit more interesting. So I'm going to write this out like this. I'm going to use the reciprocal. That means just exchange numerator and denominator and change the sign. And then can we skip a step here? No, I suppose we shouldn't. Right, let's just do it like this. X squared minus 16 over 3x plus 6. Now you can probably spot that this one over here, okay, is the difference of 2 squares, but you shouldn't neglect factorizing with linear expressions as well. Okay, so here it's pretty straightforward what you should factorize, but sometimes it's not. So it's worth just looking at what else is in the question and seeing x plus 2. Well, I think there's an x plus 2 there, so I'm thinking of some cancelling. Plus 4 and minus 4 there, plus 4. So I can sort of see where this question's going. And there's normally sort of common algebraic factors between different expressions in these questions. So x plus 2 over x plus 4, that's just the same thing again, times by. So I'm going to put x plus 4, x minus 4 in the numerator. And then what was that? I'm going to take a 3 out. So I'm going to factorize just a number out of this linear expression. So 3x plus 2. Now notice here in this kind of situation, everything's just being multiplied. So it's fine to do loads of cancelling. But if it wasn't like this, if I wanted to perhaps cancel out this 2, that's not going to work. Okay, it's part of this addition expression here. We only cancel out things when it's a common factor in everything. So what am I going to cross out? I'm going to cross out the x plus 2, the x plus 2. There's 3 times 1 over there, that's just a 1. And then these cancel out again, don't they? Okay, so all that's left on the top, x minus 4, all that's left on the denominator is just 3. Okay, let's stop the video there and let's move on to some more difficult expressions for the next part.